This video shows you a new project that we've been working on, which is for specialist internal tooling. The tooling we're using is from a company called ITS, and they produce a range of tooling which is for use on a horizontal milling machine, but it acts like it's turning tooling. So it's for components which are too big to fit on a lathe but can be fitted onto a large horizontal machining center. Some of the benefits obviously are the size of the components, plus also if you look at the component here, if you wanted to machine both ends, then it would be quite time consuming to swap the component around. But if you've got it on a horizontal machining center that's got a B axis where you've just got a rotary table, then you can just spin it round. The other thing is, of course, that it increases the depth that you can get to, and in some cases the board that you're working on might be not on the center line of the outside if it's a tubular form. So we've developed special post processor and a special machine tool simulator which shows how this works. So although we're using a horizontal machining center, we're actually using the lathe software to produce the program. So in this example here we've got a component. So if we switch on the tool animation and then just run the tool, so this just looks like a regular sort of lathe component, and if I just zoom in a wee bit more on there, you can see. But actually what's happening here is that the tooling is in the form of a cartridge where the Z movements are controlled by the Z axis on the machine tool, but the cartridge moving in and out in a diameter is controlled by a subsidiary axis on the machine, which is the U axis, which runs down the center of the spindle. So as the U axis moves in and out, the actual tooling itself moves in a radial fashion to cut the part. So you'll see more clearly when we come to the simulator. So we run the simulation, and then when we're using the simulator, we've drawn up some special tools. That the tool holder, or the arbor, if you like, has been designed as a special feature. So if we switch into this mode, and on this particular machine there isn't a turret, so the component is mounted along a horizontal table. So if we look at this in that plane, so this is the tooling here, so the component moves in and out along the Z axis. The U axis, which runs down the center of this spindle, actuates mechanisms and this part of the tooling which force the cartridges out in this direction, and that's actually what cuts the part. So if we zoom in on there and we just run the simulation, you should see how this is working. Just slow that down slightly. So the cartridge is moving ostensibly in the X-axis in and out, but it's controlled by the U-axis, which is running down the center of this special tooling system here. Now obviously there are limits to the amount of travel that each cartridge can take from a starting diameter to a finishing diameter. So there are various cartridges which cope with different diameters, and of course the cartridges use standard turning inserts. But don't forget, this is happening on a vertical machining center where the component is stationary and the spindle is moving. So if I just zoom in on there slightly. So along with the machine tool simulation, which checks any collisions for the tool tip, the cartridge or the arbor, then we can check exactly what's happening within the bore. When it comes to a tool change, then obviously the operator needs to change the cartridges between a roughing and a finishing tool. Okay, so that's it. It's a really neat application which adds quite a bit. Main uses are for heavy industry, oil and gas exploration, that type of thing. Okay,